Okay, so let's I just try to give some illustration of what are the postulates first of all in that Boolean okay, first before that I'm asking, I mean, I'd like to start with what are the laws we know in Boolean algebra. Can you list it up? In the last live session also we have discussed about the commutative law, which is A dot B, which is equal to B dot A, associative law. A dot similarly in the commutative law, that is another thing is A plus B or B is equal to B or A dot B dot C is equal to A dot B dot times of C, or A R of B plus C, which is equal to A plus B of C. Then identity laws, okay, that's other things. Then distributive law. In the distributed, how can you tell this is a distributed law? Means there is a difference of operator will be there. So here two different operator. Maybe I can, okay, first of all, in the Boolean as like normal C programming language, what is the order of precedence? Like we have some idea, like in the expression, if you have some normal expression, let's say C equal to A plus B star of C. It's just a C example I'm talking. So in the C language, which one will you execute first? Either A plus
Some
B.
multiplication.
Yeah, so the order of precedence is multiplication first, then addition. So likewise here in the Boolean algebra also we have the precedence, like parenthesis the first precedence, then inverter is the first next second precedent, then AND operation, then OR operation, finally it's a OR operation. Okay, I think I can give the same meaning. So this one and operation is dot operator and OR operator is plus operator. Okay, this is programming is Verilog. If you studying something about Verilog programming, these are the symbols for and, for or, for not, comparison not. There is another not called the tilde not is there. Okay, here we can define the not by either bar or apostrophe. Okay, so the order of precedence in this way only. The first order is I will always give her with the parenthesis. Any doubt in this regard? Okay, so if you have that expression like this, above expression like this, A dot of B plus C, in such a case what happens, it will first execute B plus C, then it will execute the resultant of that value and with A. Is it okay? Yeah, so if I have this case, I can alternatively I can write less A yeah, it is A dot B times of A dot C. Okay, any doubt in this regard? So why I'm telling like this means, if you have the expression like I just giving some random example, A B bar C bar plus A B C bar, something like this, AC plus BC, something as like this. So in this case, I can group these two things such that I can write as A times of B bar C bar plus C. Okay, this is here I'm using distributed law and I can proceed it. Okay, the same distributed law also I can use for converting these to SOP to PO, sum of product to the product of sum also. We will discuss in this in the shortly. Okay. Okay, now let's move on with the different type of Boolean algebra postulates. So one thing is identity basis. A R with 0, sorry, X R with 0 is X, and similarly x dot with 1, which is x. So when I'll get the same unknown input, so like I have unknown input called x and another known input is 0. So in the OR operator, one of the known input is 0. Okay, I don't know what is the another input. If I want to get the same output, the known input must be equal to 0, such that I will get this unknown value as it is. In the same case, AND gate, if I want the unknown input to come as output, the another input should be known value as 1. Then only I get the answer. Similarly, x plus x bar. Okay, that gives the value as 1. Okay, so it means that I have the OR gate. So one input like this, another input is inverted and provide like this. Okay, so the final answer is 1 always. In the simple, we can just think like, let's say this is A and B input. If x equal to 0, okay, the B value will be 1. If x equal to 1, then A is 1, whereas B is equal to 0. For both the case, OR operator is, what is OR operators? Any one input is high, output is high. So in this way, I can write like this. Same cases, if I have x dot of x bar, that gives 0. So I have the AND input x, which is connected to A input of the AND gate, and a B input of AND gate I am connected to the inverted input of inverted primary input, such that if okay, so output is y, input is x, and input x is connected to A, and inverted input of x is connected to B. So if x is 0, A is 0, so B is 1. Output is 0. If x is 1, B is obviously 2. Yeah. Yes, Sonali Kumari. You please unmute and ask.
I think, sir, instead of B, we should write A bar.
Okay, but in fact, I'm okay. Your this term is A bar, right?
Yes, sir.
Okay. What is my okay? Point is, this line is totally okay. I'm just talking like this. Okay, this is a OR gate, 2 input terminal. I label this input terminal as A terminal. This input terminal is B terminal, normal input terminal. Okay, and I connect A with X as it is. So now X equal to, or A is equal to X. If I connect like this, what is B is equal to? B is equal to X bar. Okay, I'm noting this 2 input terminal as labeled as A and B. Okay, as like where A is connected to X. So if X equal to 0, B is X bar, which is 1. If X equal to 1, B is X bar, which is 0. Is it okay?
Yes, sir.
So that aspect, anyhow, I'm getting answer as 0. So x A dot A bar or any expression. Okay, X is not a single literal element. Think, please expand yourself. Maybe like this. I have A plus B plus C. Okay, or in complicated like A B C bar plus A bar B C bar plus B C the whole bar, B, like something. Let's say this is F, and let's say G is equal to ABC bar. Okay, when you expand this particular thing, we get some expression. So if I say telling that what is F dot G is what is F dot G here right now?
0.
Okay, so that's the point is, anyhow, it when I simplify it, you get a single value, either 0 or 1 or some variable name, something, by substituting A, B, and C something. So here F and G are complement to each other. So F and G is equal to F bar. F dot F bar is equal to 0. If I asking what is f plus g,
1.
1.
okay, good. So these are the 2 points I want to emphasize here. And similarly, if you have OR gate and both inputs are shorted to x, so normally y is equal to a plus b, where a is the first terminal and b is the second terminal. So here y equal to x plus x. Okay, so what is the meaning of that? If x equal to 0, so 0 plus 0, 0 or with the 0, 0.
0.
If x equal to 1, 1 or with 1 gives 1. I don't have another combination because both are same term. So if both the terms are x, output is remains x. So x dot x gives x. Is it okay? Let's take some elements. AB plus okay, a plus, okay, let's have like this. What is the answer? How many gates are required? As according to distributed law, can I write like ab dot a plus ab dot b? Okay,
Should be able to, sir.
yeah,
Should be able to, sir, right?
should be,
Should be able to.
yeah. Why it so means, well, if you want to understand exactly, means let's assume that x equal to ab. Okay, then I can write the above expression as x dot of a plus b. Is it okay? According to distributed law, how can you write it up? This is equal to x dot a plus x dot b, where x is nothing but ab, which is already defined it. So ab a plus ab b. Is it okay? And now I told you this is nothing but a dot b dot a. I can write like this way also, right? Can I group like this? Either I can group like this or I can group like this. Am I right? Both are give the same answer because according to the associative law. Am I right?
Yes, sir.
So I just choose this one. According to the commutative law, if I have b dot a, I can rewrite as a dot b. Am I right? So this above element can be also written as a dot b. Is it okay?
Yes, sir.
Again, as same process, I can group it up. What is a dot a? Just now we have discussed.
A.
Okay, a dot this term b. Similarly, a dot of b dot b. A dot this term is b. Okay, finally a that is, this is again same, this left hand side and right hand side, and before the argument, I mean argument 1 and argument 2 are same value. So what is answer? X plus ex. It's just look like just now we have discussed what is x plus x is equal to x, like this we have discussed, right?
AB.
So it is equal to ab.
AB.
So if I have the above expression ab of a plus b, okay, there is no need to make like these two number of gates like this and the gate. Then this is a and b. This gives a dot b. This gives a plus b. The total term should be and together, so that I can write it as again a like this. This is equal to ab times of a plus b. Instead of this, I can simply put okay, that is equal to the above expression. Is it fine? So I'm reducing number of gates. Is it fine?
Yes, sir.
Yeah. Any question regarding this? Okay. So next one, very important theorem, which is distributive De Morgan's law, or De Morgan's theorem. Okay, the theorem is just like this. What is A dot B? If I have A dot B the whole bar, yeah,
So
Going to distribute with a positive sign.
sorry.
And gate exchange with OR gate and
Oh, you're giving the answer for this law. Are you going to
yes,
give
sir.
the yeah?
A bar
Okay, A bar or
A
with
plus
B bar. Okay.
B bar.
So what is the meaning of it? This is nothing but an NAND gate. Okay, with a non-complementary input. Inputs are not a complement. It is giving directly a input. No complementary input I'm giving here. Okay, that gives A dot B, the whole bar. This is equivalent to that of a complemented input A and B. Okay, it is complemented. Give that value to an OR gate. Or I can rewrite the above expression like A and B if I draw like this, the input of OR gate is complemented. That's the meaning of it. So the above two things are equal. Okay. This is theorem 1. Similarly, if I have A or B, which is an OR gate, that is equal to the equivalent to that of complemented input of AND gate. A bar dot B bar. Is it fine?
Yes, sir.
Yeah. So far, any question regarding this?
No, sir. Sir,
Okay.
have you studied XOR gate?
Have you?
Have you studied XOR gate?
What is the meaning? What do you want to do? How to implement XOR gate, or what is your question? I couldn't.
Have you studied XOR gate?
We studied XOR gate. What is?
Till now means I am little bit late in GMeet.
No. We didn't
No,
discuss about the SR now. Yeah. Okay, Sonali Kumar do you have any question?
Yes, I have a question regarding the previous means
Yeah,
that
please.
removing the yeah, sir. This one. So removing a logic gate, how that it impact on devices?
How did that back on devices in the sense?
Yes, sir.
Okay. I mean, how both are equal? Is it so? You're asking like that?
No,
Also,
sir. That I understand it. I am asking about the devices.
what are you asking about devices? I couldn't hear. I didn't understand what is your question, ma'am.
So actually, as you explained this, removing a logic gate, that three logic gate converted into one. So how does it impact on devices?
Okay, so a point is this particular functionality. Okay, by using of this number of gates and performing the above functionality, can be replaced by the simplified form of this function. How it did so means I do some process, right? So far I did process 1, process 2. These are the process. Finally, I concluded that total above expression is equal to that of A dot B. this is called a simplification process. What is our role of simplification? Means I don't want to use unnecessary or redundant the gates again and again. See here, unnecessary a plus b is there. Similarly, and the result is not at all meaning for here. I suppose to use that result of a plus b with the AND operation of second level. This is a level 1 means. If this is a level 1 means this is a level 2. Okay, this is not at all playing any role. Just let us just have a look again. Okay, this is the circuit which I draw before, right? A dot b dot of a plus b expression. Okay, let's say y is equal to this and this is our y expression. If I'm giving a equal to 0, b equal to 0, what is the answer for both the output of first level? Both are 0, right?
0. Yes, sir.
Finally output is 0. Okay, now this input is 1. Anyhow, this is 0. This line becomes 1.
1.
Okay, if one of the AND gate input is 0, what is output?
It's 0, sir.
Okay, so what happens? This line only preventing to produce output 1. This line is preventing to produce output 1 so far to produce a output 1. If this line is 1, then it will produce 1. If this line is 1 and if this line is also 1, then I will get the output 1. But if this line is 0, whereas this line is keep on changing from 0 to 1 or anyway, it is not producing output on. So finally, what is which input y is equal to 1? For which a equal to value and b equal to value, output y equal to 1?
Both A and B have to be 1.
Should be 1. Then only I'll get the answer. So in the OR gate, okay, OR the gate operation, if any one of the input is high also, I will get output high. But in the AND gate, both should be high. So finally, what happened? This logic says both will be high. Now only I get output high. So it means that this is not playing any vital role, and this is also not relevant. So finally, I can say this is equal to a dot b. Can I simplify like this? So our logic is when y equal to 1 only when both the inputs are high. This is a statement as it gives. Am I right?
Yes.
Yes.
Okay.
Yes, sir.
So that's why I can simply tell in why unnecessarily we have to use OR gate and one more AND gate. I simply tell output will be high only if both inputs are high. It means when I connected to AND gate. How do I know it? Do I want to cross check like one by one? Here it is just 2 input. Think about n input. In such a case, it's quite complicated. So the Boolean law is helpful for you. Like previously I mentioned, like what is that? A dot b dot a plus a dot b as expanding using distributed laws and so on. Finally, I can simplify it as it is equal to a dot b, like several simplification method just now I discussed, right? Based on that way, I can do it my work simplification very fastly. Otherwise, it is time consuming by keep on validating each and every each and every value input values. Okay. Any doubt in this regard?
No, sir.
No, sir.
Okay. Okay, then week 5 is released or not released? Sorry, week 4 is released or not?
No, sir.
Okay, fine. Well, if week 4 released, then we can discuss one more point from this, which is called as minterm and maxterm. But anyhow, no problem. We can discuss that in a later part also. Okay, then what else we can discuss? Yeah. Okay.
Sir, let's solve some problem in De Morgan's law and all that.
Yeah, you can solve some De Morgan's law problem.
Sir, I have some doubt in practice assignment, sir. Big
Sure.
3.
1 second. Give me 1 second. I open the portal, and then we can solve some of the problem which are related to the week 3 content. I mean, using De Morgan's law. So week 3 practice assignment. Which problem?
Sir, can you share data screen also, sir?
Sure.
Sir, in problem 2, sir, I solve it and I get option A and option D both are correct, sir.
Okay, let's check that one. Okay, it is related to the question number, previous question number. So let me take that one. Okay, fine. So if second question you asked, right?
Yes, sir.
Yeah. So if all the NAND gates are replaced by NOR gate in the circuit 1, okay, only NAND gates are there. This is equal to P, and these two things are shorted together and produce another NOR gate, and I am giving to another NOR gate, and the final answer is connected to NOR gate. Okay, so what is a simplified expression? So if you want to solve this, what is the expression? You have to first write it out. So this line I can call as, let's say, A, B, C, D, and all. Okay, where A is equal to P plus Q the whole bar, where B is equal to Q plus R the whole bar. Is it okay?
Yes, sir.
Okay, then what is C equal to? A plus B the whole bar. Am I right? And D is equal to C bar. Is it fine? Because it is just an
Yes,
here
sir.
it is just an inverter, so I can tell that D is equal to A plus B simply. Can I call as A plus B, or A plus B the
Yes,
whole
sir.
bar of whole bar, which is equal to A plus B. Okay, then what is A plus B? Where A is equal to P plus Q the whole bar plus Q plus R the whole bar. And finally, what is Y? This answer, this term R with, what is this term will be? P plus R. P plus R the whole bar of whole bar. Is it okay?
Yes, sir.
Okay, so I can simply rewrite as P plus Q the whole bar of whole bar dot Q plus R the whole bar of whole bar dot P plus R whole bar of whole bar. In what basis I did written like this?
De Morgan's law.
Basing De Morgan's law. So then I can write as this is equal to P plus Q dot Q plus R dot P plus R. Okay, is it fine?
Yes, sir.
Okay, there is 3 input AND gate, and the AND gate will be 1. When the AND gate will be 1, this line should be value 1. This
One
two,
of the input is going to 1.
so ultimately these 3 sum term need to be 1. All 3 sum term need to be 1. In this case, R gate is there. Either P is to be 1 or Q equal to 1. So I can tell PQR either P or Q. Maybe I can consider Q or P. In the second case, Q or P. Okay, either Q or R. Am I right? Yes. Okay, fine.
sir.
Let me. In the first sum, these two will be high. Second time, these two may be high. Third time, these two may be high. Am I right?
Yes, sir.
Okay. In this case, what I am supposed to tell is, if I have P is high or Q is high, output will be high. Am I right? Or Q is
Yes,
high
sir.
or R is high, output will be high. I need at least
Yes, sir.
two P or Q must be high. Either P or Q must be high, or Q or R must be high, or all three must be high.
Yes, sir. Yes, sir. Got it.
Okay, any one to be high, any two to be high. Oh, what is the answer we get?
The correct
One.
answer,
All the inputs to be
option D,
was
sir.
one. Okay, that is also a third option. I told you, like PQ or PR or it means they are considering all need to be one. Fine. Anyhow, at least two to be high is enough, because either P or Q is high. What happened? If suppose P and R is high, means what happened? Let's have P, Q, R. This two high, this is 0. What is this answer? 1 dot 1 dot 1. Am I right?
Yes, sir.
Or
Yes, sir.
if I have 0, 1, 1, that is P equal to 0, Q and R is high. Since Q is high, this is again 1. Since Q is
One,
and R
one.
high and high. So at least two input line should be high.
Yes, sir.
Okay, if all inputs are high, again it is quite easy to tell that it is simply straightforward that everything is high. That is also a valid answer. What is your answer?
Sir, I get option A correct and option D both.
Exactly one input to be 0. Yeah, that is also valid, right? Because if at least two input is high, another input need to be 0.
Yes, sir.
Exactly one
Yes,
input need to be 0. That is also a valid case. Okay. That's also what you're telling, that it is remaining two line. This here 3 input line. Exactly one line to be 0. Remaining 2 lines must be 1. That is indirect statement you are telling. Okay, that's also valid and statement.
and sir, another problem number 6.
Okay.
Here I get an or as an answer, sir. But it's so NAND.
Okay. Okay, let me check it up. So I want y is equal to ab dot cd. Okay, the first output line. So gate 1 takes something like p something of q something else, like where p is nothing, maybe considers it is ab the whole bar, and this should be cd the whole bar. Am I right?
Yes, sir.
Okay, what's supposed to do such that I will get the output as AB plus CD? If I put dot and that is equal to what? AB the whole bar of whole bar plus CD the whole bar of whole bar, that gives AB plus CD. NAND gate. So simply I will tell you, if you want A plus B like this, okay, using NAND gate, what you supposed to do is take these two terms is the inverted value and give to NAND gate. Give it to NAND gate.
Yes, sir. I got it now. I misinterpreted that as a AND gate. That's why.
Okay. So De Morgan makes you to simplify these things. So I'm having some expression like this, means you can make it up like this. If I want A dot B, what you supposed to do is you can use A inverted, B inverted, use NOR operator. Give that inverted input of A and B to the NOR gate such that it gives what? A bar the whole bar dot B bar the whole bar. It is equal to A dot B. Is it okay?
Yes, sir.
Yes, sir.
Yeah. So let's have discuss something in the which is discussed in the lecture also. What is A XOR B is equal to? It is A B bar plus.
A B bar plus A bar B bar. A bar
Okay.
B.
Okay. So I want to implement the same operation using NAND gate. I think it is done in the lecture itself. Next, let us try to implement the same thing in NOR also. Okay. Tell me how to do it. So
sir. Can you please repeat?
I just want to implement the same expression using NAND gate.
So basically, you convert AND gate into NAND gate.
Okay,
By
number of
putting,
NAND. Okay, well, another main concern is you should not use more number of NAND gate.
So basically, you put a inverter in the front of input.
Well, can I write this above expression like A plus B times of A bar plus B bar?
Yes, sir. By the De Morgan's law.
By the De
I think
Morgan's
so.
law, we can write like this. What is this is equal to?
This is equals to like XNOR gate. I think.
No, please listen carefully. This is okay. First of all, how many of them are not worried about this term? Is it okay for everyone?
No, sir.
Oh, sorry, sir. My
Yeah.
mistake. Sorry, sir. It's a
Well, I'll just write out this in A B bar plus A bar B, which is equal to A plus B times of A bar plus B bar. How it so means you can just understand with the help of De Morgan's law. So I consider this is A B bar as it is. Let's say this entire term as something X. So that can be written as A B bar plus X, which is equal to A dot X, then B bar dot X. Is it okay? Somewhat best, plus B bar I think I was wrong. It can be written as A plus X times of B bar plus X. Is it okay?
yes, sir. Now it's
What is X is equal to A times of
A bar.
A bar B times of B bar plus A bar B. Is it okay? That gives what?
Yes, sir.
Again De Morgan's law. Sorry, against distributed law. A plus A bar times of A plus B times of B bar plus A bar times of B bar plus B. Okay, A bar plus A is
Yes.
1 or 0?
1.
1. If it is 0 means entire time will be cancelled. So it is 1. That's why I'm just simply neglecting it. It gives 1 dot of anything is 1. So finally it is equal to A plus B, A bar plus B bar. Is it okay?
Yes, sir.
Again this can be written as A plus B times of A B the whole bar.
Yes, sir. By the De Morgan.
Okay. And if I want to do some simple tricky operation, what kind of tricky operation I want to do it? So
I have some problem in De Morgan's law. So
okay.
if you
No, you want to solve some problems in De Morgan's law.
yes, sir. I have.
Okay, I'll just
So
do.
basically,
Yeah,
I am
please.
speaking. Then you can you write.
Yeah, speak.
A bar plus B bar.
This one, yeah, this is the whole bar. Please listen. This is A B the whole bar. That is A bar plus B bar. I have.
It's a question.
Okay.
It's my question asking you.
Okay. Okay. What is your question?
A bar plus B bar.
A bar plus B bar.
Whole bracket.
Okay.
No, sir. No, whole complement. I am not saying that whole complement. Whole bracket.
Oh, whole bracket.
End with B bar plus C bar.
B bar plus C bar.
Now take whole complement.
Okay. So you want to simplify this
Yes.
one.
Yeah. Yes, sir.
Okay. Let's if you for the beginning level, what I am supposed to do is this is X first one, second term as Y, this entire term as X, and this entire term as Y. Like this, you imagine this is equal to what? X bar dot Y bar. Am I right?
No sir, dot नहीं plus आएगा. Plus.
X bar plus Y bar plus.
Sorry, x
the
bar
department
plus y bar.
knowledge.
X bar plus y bar. So what is x bar? So first, what is x? It is a bar plus b bar.
A
Am I
bar plus
right?
B bar.
Now
Yes, sir.
x bar if I want to write in the form of x bar, I put whole bar plus what is y bar? B bar plus c bar.
Yes, sir.
Okay. What is this is equal to? It is equal to a dot b
A
the
dot
whole.
B.
Am I right?
Yes, sir.
This is equal to
B dot C double bar.
the double bar get cancelled. That gives ab plus bc. If you want to simplify further, this is equal to b times of a plus c.
Yes,
But
sir.
this is not always preferable. This is a preferable way. Why it so means the level 1 in the level. Okay, how many levels I have means I have to give AND gate a, b and c, and this is result to be given to OR gate. So this is your level 1, which is directly connected to a primary input, and next level is the output of the level 1 is connected to the input of gates. That all the gates are called as a level 2, and finally it comes to number of levels. That depends on the circuitry, but point is that in the level 1 all are same gates, AND gate is AND array, and the level 2 it is only OR gates in this example. So it is fixed acceptable. Whereas in this second case, which is already also equal, how I say means first level is OR gate, second level only it is connected to AND gate. Okay, there is a chance of if the expression is different, if you there is a chance of putting some AND gate here also in the level 1. So the mixing up RL AND gate is not acceptable in the same level. Okay, it's okay, it's working, it behaves properly, but point is please avoid it. That's why we are avoiding mixed process. Okay.
Yes, sir.
Well, now back to this problem. So how can I write this particular term? I just want to implement using NAND gate only to implement A XOR B.
You can put double complement. You can take.
So A or B OR gate and AND gate. Okay. What is OR gate? OR gate can be written as A bar dot B bar the whole bar. Am I right?
Yes, sir.
Okay. Then that gives answer as OR operation. If I put one more bar, no. This is nothing but NAND gate. This totally is an AND gate operation. Am I right? NAND gate final with OR gate, AND gate. One NAND gate, two NAND gate, 3 and 4 NAND gate plus one AND gate. Totally five number of gates are required, but actually we can implement even lesser than that also. Okay, how can we solve it? Any other idea?
No, sir.
Something we have to plan accordingly. How can we do it? So, okay, normally let's try, then we can proceed with this. Okay, let me try with normal method. Okay, this is the expression I have. So A term, B term I connected to AND gate. It gives A and B. Am I right? A and B bar. Am I right?
So this is a AND gate or inverter?
NAND gate can also act as an inverter, right?
Okay, sir.
If I give both the input to the same terminal, it is just an inverter. Even NAND gate or NOR gate,
got
both
it,
can
got it.
act as inverter. Okay,
Got it.
then, well, if I give this thing to this, what happens? I'll get A bar, A dot B bar, the whole bar.
Yes, sir.
Okay, if I give another NAND gate, it gives A dot B the whole bar of whole bar of whole bar, which is equal to the same value. Am I right?
Yes, sir.
Okay. Similarly, I'll take A term connected to NAND gate, it gives A bar. B term as it is to here, it gives A bar dot B the whole bar. Okay.
Yes, sir.
Well, if I give this to another NAND gate, it gives A bar dot B. Okay. If I connect these two things to OR gate, that's it. I'll get the answer as A XOR B. But previously I told you what is A bar plus B bar the whole bar?
A dot B.
A bar dot B bar.
Okay. Sorry. Dot times of
A plus B.
A plus B. So if I connect NAND gate with the inverted input, I'll get the uncomplemented output. Am I right? Of OR operation. So
Yes.
here I have the complemented value, two complement value. If I give these two complemented value, instead of this way, if I connect to this way, to this case, A dot B the whole bar a whole bar, A bar dot B the whole bar, that gives, or else simply can take this is X bar, this is Y bar. What is the answer?
X bar dot Y bar.
X bar dot Y bar the whole bar, which is equal to,
Whole bar. Yes, sir.
this is equal to
X plus Y.
simply X plus Y. What is X?
A bar dot B bar. A dot B. A bar dot B.
This is X bar. Then what is X?
Oh, sorry.
So your X bar is equal to ABB the whole bar. Then what is X? AB the whole AB bar. Am I right?
A bar dot B.
Y is A bar dot B. Yeah. So this is your expression. Am I right?
Yes, sir.
So ultimately we are done with the 5 number of NAND gate, but in the lecture this further lesson the 4 number of NAND gate is sufficient to implement this above expression.
But
Okay.
sir, I am saying in the starting of this question that we can draw with simply just AND gate first of all, and then implement AND gate to the AND gate. Implement NAND gate to the AND gate.
Okay, you are talking that let's start with simple and or architecture based, then inserting bubbles at different and backside such that it will convert to NAND operation or respective OR operation.
Yes, sir.
That's okay.
Yes,
That's
sir.
also acceptable.
Yes, sir. Thank you.
Okay. So any other question from the week 3 content? So well, we can solve some of the problems. Maybe I can try. Okay, I'll just try this particular problem. Randomly, I'm choosing some number. Let's check. Yeah. Let's say
I have a problem, sir. Also, if you have any topic to discuss.
Only one term. I just finished up, and then we can discuss that also. Please. Is it okay?
Sure.
Okay.
Sure,
Let's
okay.
start with simple variable A bar B plus AB bar plus AB. So what is a simplified expression? What is the y value? When y will be high? If I give like this expression, what do you supposed to? How can we solve it? So can I group like this? Anyway, we can group. One of the way of grouping, I'm just trying this.
It's a question for students or
Yeah, it's question to you all.
okay, sir. Wait a minute. Answer is 1.
Yeah. Thing is, we are taking a bar from these two terms so that it gives b bar plus b plus here a taking common b bar plus b. Okay. The necessity of writing this simple expression is meaning what is the need is that instead of two variable, if I have n variable, then also this kind of process to be happen. So what is the law you are used here? That's the question. Here you bring up these two product term as a this way. Sum of products, product of sums. Two sum of two sums. Two sums are produced here. One sum is a bar, another sum is b bar plus b. How, which law is used here? Can you relate these two things with one law?
Distributive.
Exactly. So based on distributed law, we are bringing it up. Now it is again looks like b plus b bar. Maybe you can simply write as b plus b bar is equal to 1. But for time being, let's check. Let's x equal to b bar plus b. So our expression will be looks like this dot x plus a dot x. Then again it is equal to a plus a bar times of x. Is it okay?
Yes, sir.
Okay, we know that this is equal, then it is equal to b bar plus b. Okay, again I did with distributed law only, and this is equal to 1 dot of 1 equal to 1. Simple, we can do it. So but let's give some other example. Let's check let's take this number, um, a bar, b bar, c bar, d, or uh, a bar, b bar, c, d bar, or okay. Can you simplify this expression? I think I was wrong. This one. Yeah. Yeah, now it's okay. Yeah, fine. You just try this one and come with a simplified expression. Okay, in the next class. Those are other class you may leave. Okay, finally we have a few more minutes. If possible, you can solve now also.
answer is for C XOR D.
Okay, let's try that.
Is it right?
Let's check it up. So I can take A bar B common, so that it becomes C bar D or C D bar. Then the next set I can have AB common, CD plus CD bar. So finally I can tell that CD plus CD the whole bar common. That gives A bar B bar plus AB. Am I right?
Yes, sir.
This is equal to C XOR D and with A XOR B.
Yes, sir.
Okay, so I just want to emphasize one term from this expression. I given A bar B bar C D. I think C. Okay, so what is this is I can reduce it to A bar B bar times of C bar C XOR D. I got this kind of simplified terms. Why? What is under inference from here?
What, sir?
So this from this about expression, I simplified or not simplified. The operation wise, I'm simplified. Instead of AND gate and NOR gate, OR gate, I simply use a single XOR gate. I can produce this. I think I was my question is wrong. I think so. Maybe I can. Yeah, maybe I can remove this part. Okay, let's have this one. So what is your answer? This is fine. So what does it use?
So basically, you can take in common A bar B bar.
So finally, answer is
I'm not calculated final answer.
it is A bar B bar. Final answer. Oh my gosh, C bar plus
Yes,
C is turned to be 1. So
yes, sir.
I have 3 literals in both the product terms. And when you look at it, it is equal to that of. I can call if I concatenate like A comma B comma C as a binary number system base. This is equal to 0 0 0. And this is equal to
Yes, sir.
0 0 1. And
Yes,
these
sir.
two numbers are only 1-bit number variation. If only 1-bit variation is there, 3 literals comes to 2 literals. Okay, 2 cells or 2 groups can be reduced to one cell. I can again rephrase it. 2 values or 2 product term with a single bit variation can come to a single product with one reduced literal value. Let's have another example. Let's have this expression. Let's have like this A bar B bar C bar plus A bar B C plus A B bar C bar plus A B bar C. So I have 4 terms. Okay, I have 4 terms, 4 product terms. Sorry, where it is. Yeah, I have 4 product term. When I simplify it, what is the answer? I can take A bar B bar common, then C bar plus C plus A B bar common, then C bar plus C. It comes cancelled. So finally it becomes A bar B bar plus A B bar. Am I right? Again, this is equal to B bar of A bar plus A, which is equal to B bar. So point here, what I want to emphasize here is A bar B bar C bar, which is 0 0 0. A bar B bar C, which is 0 0 1. Then A B bar C bar, which is equal to 1 0 0. Then A bar B bar C, which is equal to 1 0 1. Okay, So if I group these two things, okay, only these two literals comes to be finishing up. And I group these two things, two literals will be there and one literals will be vanished. Okay, is it fine? Number of elements is reduced, simplified element is reduced. Now think about it. Here it is 0 0 is a common element, here 1 0 is a common element. Again, number of variation between these two things is only one variation, one bit is varying, not multiple bit varying. Here also one bit varying, hence I can group again these two grouped element such that it will produce with a single literal element of this.
Yeah,
Yeah,
sir.
okay.
Understand. It's coming in like similar with the TMAP solving method or something.
Exactly. And if you
Got it.
want to
Got it.
march towards the Karnaugh map without actually what is the meaning of it means I'm just implementing with the help of Boole law only. That's why I'm telling you.
Yes, sir. Yes, sir. Got it.
Okay. And if these are adjacently, it is there only. You can. What do you mean by adjacent? Only one bit variation need to be there. Okay, that's it. So any questions? Any other question do you have?
No, sir.
Okay.
So can you move into previous slide, sir?
It's this one.
And yeah, this one, sir. How you written down that C bar D plus C D bar equal to C X or D? Can you explain that?
This is a XOR expression, right?
Yes, sir. Simply XOR
A bar B
expression.
plus A B bar. Instead of A and B, I am putting C and D. It is C D C D. Very little only different. Remaining things remains common thing only, right? Where is your question? Do you have any other question? I mean, is my understanding is wrong, or am I clearly understand what is your question?
Yes, sir.
Okay, so you want? I mean, up to this stage you understood, right? How I
Yes, I understand.
yeah.
Yes,
If
sir.
it's so okay, if this is a problem, then you have to think this stage. So I just take this C bar D plus CD bar. Here also C bar D plus CD bar. Now the two terms are same term. I'm just taking as a common term, like distributive loss.
Yes, sir.
Okay. Okay. Thank you.
Thank you, sir.
Thank you all.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you,
Thank you, sir.
Thank you. I hope any other question. If I have no question, if there means you can wait and ask.
Sure, sure.
Thank you.
Thank you, sir.